After completing this lesson, you will be able to achieve these objectives. Explain how Network Access Control, NAC, works to protect networks. Describe the evolution of NAC, including the introduction of BYOD and IoT devices. Identify additional NAC capabilities. List the benefits of using NAC. Network Access Control, or NAC, is an appliance or virtual machine that controls access to a network. It has complete visibility into the network profiles and categorizes devices automatically. It evaluates and classifies security policy compliance by user, device, location, operating system, and other criteria that may detect unusual activity. Many NAC solutions have centralized architecture that improves the control of devices across large and multi-site networks. NAC began as a network authentication and authorization method for devices joining the network, which follows the IEEE 802.1x standards. The authentication method involved three parties: the client device, the authenticator, and the authentication server. The authenticator could be a network switch or wireless access point that demarks the protected network from the unprotected network. The client provides credentials in the form of a username and password, digital certificate, or some other means to the authenticator, which forwards these credentials to the server. Depending on the outcome of authentication, the authenticator will either block the device or allow it to access the network. Another method to control access to a network, especially a publicly available network, is a captive portal. An example of this is when you connect to a network in a coffee shop. Before gaining access to the network, you may have to interact with a web page that asks you to agree to legal terms before granting access. As endpoints proliferated across organizations, greater controls were needed. Guest access, bring your own devices, BYODs, and the Internet of Things, IoTs, have introduced complex problems for network security. The first is that the devices trying to connect to the network are personally owned devices, not assets of an organization. The company's MIS department does not control what runs on these devices, for example, antivirus software or unsafe applications. A second challenge is that IoT devices are hardware with sensors that transmit data from one place to another over the Internet, dramatically expanding the attack surface. Organizations buy IoT-enabled devices from other vendors, and these devices connect back to vendor networks to provide information about product use and maintenance needs. Organizations tolerate this situation because IoT devices save them time and money. For example, if a printer is low on toner, the vendor could notify the network administrator by email, or even deliver new toner cartridges automatically. Organizations tolerate using IoT devices because it saves them time and money. The evident convenience of these devices has made them wildly popular and numerous. However, the variety of devices, the lack of standards, and the inability to secure these devices make them a potential conduit for contagion to enter the network. Many IoT devices lack the CPU cycles or memory to host authentication and security software. They identify themselves using a shared secret or unique serial number, which is inserted during manufacturing. But this authentication scheme is very limited. Should the secret become known, there is likely no way to reset it. Without the ability to install security software, there is little visibility into those devices. Fortunately, NAC evolved to solve these weaknesses. When MIS introduces NAC into a network, the first thing NAC does is create profiles of all connected devices. NAC then permits access to network resources based on the device profile, which is defined by function. If a device does not have a defined profile, or a profile that matches a particular function, they are denied entry. This is like granting individuals access to sensitive information and applications based on their need to know. For example, NAC can permit an IP camera connection to a network video recorder (NVR) server, but would prevent it from connecting to a finance server. Based on its profile, an IP camera has no business communicating with a finance server. NAC will direct the IP camera to its appropriate VLAN, and the firewall would do the rest. When access is granted this way, the network becomes segmented by device function. If a device is compromised, malware can infect only those objects that the device is permitted to connect to. So the compromised IP camera from the earlier example could infect the NVR server, but not the finance server. This is also applicable for any contractors, partners, and guests who may need to enter an organization's network. In this case, these users are segmented by profile and can gain secure access to the network while being locked out of restricted areas. To ensure that the network remains secure, user and device policies are adjusted as people, endpoints, and businesses change. With the prevalence of Wi-Fi hotspots in public locations and company offices, there is a need for temporary guest access to these networks. NAC enables an organization to manage and authenticate temporary users and devices through a self-service portal. An example temporary guest access is someone accessing a free Wi-Fi network at an airport. NAC can be integrated into the security framework so that when a breach is detected, NAC automatically responds to notify the Security Operations Center, SOC, and coordinates with other security devices to neutralize the threat. It can also generate reports and insights in attempted access across the organization. NAC integrates with other security point products such as switches and network solutions through the Open, RESTful Application Programming Interface, API, or Secure Shell, SSH. Network access control is important and helps an organization through the following. Click the icons to learn more. Fortinet offers a network access control solution named FortiNAC. It contains all the features identified in this lesson, as well as additional features. FortiNAC easily integrates with the Fortinet security fabric and can automatically isolate clients if they are not adhering to the set policies. You have completed the lesson. You are able to explain how network access control, NAC, works to protect networks, describe the evolution of NAC, including the introduction of BYOD and IoT devices. Identify additional NAC capabilities. List the benefits NAC has for an organization.